Hey everyone, my name is Jay Hosfeld. I'm a lead animator at Epic Games, and today I just want to talk to you about animation in Unreal Engine 4. A little bit about like the philosophy that's driving what's driving the features, what's causing our decisions. So what I kind of want to do is start at about 2 years ago. We sat down and we were asking ourselves like, where's the future of animation going for game developers? And we kind of just had to think about what is true. So the first thing that's true is that animators are your best resource for animation. There's currently not an animate button that does it for anyone. And so we want to empower animators. The second thing that is true is that more and more devices that stream animation input into game engines is coming about. Stuff that's cheaper than a big Vicon mocap studio. So things like the Vive Pucks, even iPhones that can capture your facial movements. So we want to embrace all this stuff. So it comes in two parts. So one is being very accessible by developers and your animators. Fast iteration times, because like I said, your animator is your most valuable asset on your animation team or your development team when it comes to animation. And also the freedom to work how you want to. We don't make Unreal Engine 4 just for AAA titles, but we want to support indies. We want to support people who may not even have animators. They may need to buy animation data from somewhere else and then modify it. So this is what's been driving our decisions and the features that I'm going to cover. So what I will be covering is animation recording, which is something we've added over the past couple years, but we've added a lot more features to it. Iteration improvements, live link, retargeting, runtime rig, pose assets, and then I'm going to cover virtual bones at the end. So the first thing I want to cover is animation recording. Several years ago, animation data could come into a game engine, but not necessarily leave it, even though the game engine is doing a lot to modify animation. So we have animation recording, and it's pretty ubiquitous throughout the editor. You can record the output animation of your animation blueprint. So if you are modifying, blending two animations together, you can hit record. That will record a new animation asset that is a U asset. Or you could also export it as an FBX and bring it back into your DCC app and bring it onto your animation rig and modify it further. So now we have animation data going both ways. You can also just load up an animation sequence. We do have animation layers, so you can actually open up a U asset animation and you can modify, let's say, the rotation of the head and add some keyframes on that. And of course, you could record it and export that animation. So what I want to cover today is gameplay animation recording. And this has been huge for us as it actually has helped us in a lot of different areas. So we have a panel where you can basically, it's called Sequence Recorder. You load up Pi and you can add your main character to the sequence recorder. And then you can simply just play the game. And so in this case, I added my main character, hit record. And in this case, I'm going through and I'm doing jumps and I'm doing a lot of animations that actually aren't the result of one animation asset, but they're the result of all sorts of additive blends and maybe upper lower body blends, montages that are being streamed in. And then once I'm done playing and I hit stop, I now will have an animation asset. So let's wait for this to load up here. So I will warn you guys, I have more videos than text on my slides because I'm an animator, so I speak with moving images, I guess. Okay, so here I have the sequence recorder, and you can see that I actually have a sequencer set up. Like I essentially have a little cinematic from the gameplay that I just did. And I can go through and scrub it and watch what I just played in Pi. And I could also load up this asset right here. And what this animation asset has recorded is every notify event. So let's say I had 5 animations that triggered during this recording, and they all had their own notify events during them. All those notify events you can see were recorded right here on the screen here. And if you have custom animation curves, all of those are recorded as well. And see, you essentially have now you have this big long animation asset that you've recorded, and you could use it for multiple uses. So for one, like me as an animator, a lot of times I'll actually export this back out to Maya and just kind of go through and scrub through and just see how my blends were working on the bones themselves. Or I will, it'll essentially give me the data that I need to like watch how the capsule moves. So we use it for debugging a lot. So here's an example for capsule movement. In this case, I brought my character into the game, and I wanted to see what the in-game physics was doing to make a capsule move up and down. And that way I could animate my character for it. And for those who are new to animation in Unreal, basically we're using capsule physics. When you play the game, we're actually just moving a capsule around with very simple pawn physics. And we animators, we essentially animate a character to look like they're the ones that are moving. I often use the analogy of a mime in a birdcage. And this is the birdcage, this is the motion. And so what I do in UE4, I play Pi, and I'll have the character like run right or left or jump off a ledge or do a jump. And then we can animate to that capsule. And it gives you a more precise animation cycle that matches the physics from the game. Another use, a big use we use for animation recording is for a lot of the cinematics you see, the trailers for Fortnite. It would take a long time for animators to create a bunch of custom animations, but we're also showing off a lot of gameplay. So we can actually just record a gameplay session, and we have a multitude of animations we can just throw back in to the sequencer. So it's kind of like a poor man's way to make cinematics, and we actually use it quite a bit. And so just to re-go over that, so we use it for debugging. We also use it for rapid prototypes, sometimes just creating a new animation asset from recording the blended result of two other animations. We use it for scripted animations, doing the capsule animation referencing, like I said, and just creating animations for a sequencer. You could also use it for, let's say you have a scripted sequence in a level where you don't necessarily want AI to cause a character to like walk from a door, turn around, walk to another door. You can record someone playing that in Blueprint. That's your new animation. You're not using AI for it, but it's giving you a nice in-game gameplay sequence. So we've used this a lot. This has been like a game changer for us. The next thing I want to cover is iteration improvements. Several years ago, before Unreal Engine 4, the normal way for an animator to get their stuff in game was they would get a list of, say, 20 animations, you do your cycles, and you would hand it off to a gameplay programmer who would plug those in. And the iteration time was relatively, it's absolutely slow, because sometimes it would take 2 or 3 weeks to see your result. With UE4, we obviously wanted to put more of the power into the animator's hands to at least prototype and set up their animation blueprints. So we're continuously speeding that along. And so one thing I do want to cover how many animators are in here by chance? All right, we have a couple. Do you guys use the auto import for your assets much? So essentially, it's just a listener. It looks at a directory where your FBX are being exported to, and it'll automatically, the minute, say it's Maya exports that animation, it will bring that into the editor. So by the time you Alt-Tab over to UE4, it's in. That's a feature that's been in there for a while, but I've noticed a lot of people don't use it. Even at Epic, a lot of people skip over this. But this is really huge to starting the fast iteration time, where we almost want to blur the lines between DCC apps and UE4. So here's an example of that. Like right here, I have a run cycle, and let's say I have a designer sitting over my shoulder, and they're like, hey, this it would be really nice if this character could hold a sword over his head while he runs. Well, I could very quickly Alt-Tab over to Maya, quickly modify the animation to like say, hey, is this what you're looking at? Of course, this is a very quick example of how to do this. This is a very fast animation, so let me copy the pose to the end. Okay, so at this point, I can just hit export. and this is Maya. So I'm hitting export in Maya. By the time I Alt-Tab over to UE4, that animation is going to be in. And also notice that I never quit out of Pi. Pi is continuously running here as well. And so it's just a fast, iterative way to modify and prototype animations, especially if you have someone at your desk, like a designer who wants to kind of see what results you both want. But the biggest thing that we've just recently added, it was an experimental item in 420, but in 421, it is now a legit feature that is not an experimental, it's not under the experimental panel anymore. And this is live AnimBP compile. And so just like the auto import would allow you to re-import new animations, you still had to quit out of Pi if you ever made a change to your animation blueprint. If you were wanting to change a blend time or add in a new animation, you had to quit out of Pi. And that slows you down. If you're doing this 20, 30 times a day, it slows you down. So for this example, while I kept Pi running and the game running, I just simply switched it to an emote animation rather than the idle, just to show you guys an example. And I keep it running. So we're at a point now where animators can keep Pi running all day if they like, and we're not having to close things down. And in this example, it's actually a very simple level, but a lot of times the level you're testing animation on might have a location you have to run to. And so if you're quitting out of Pi, then you're suddenly having to do all these other steps to get back to that the situation you're in to actually play a specific animation. And this allows you just to keep it all live, keep it on all the time. Another component we've added is Live Link. This is another huge thing that has really modified our pipelines. So Live Link is a plugin. It brings in a node onto your animation blueprint, and that node essentially works like an animation sequence player or a slot. And you could have the Live Link node anywhere on your Anim blueprint. And that Live Link will listen to Maya or Motion Builder and some other apps and stream in that data real time. And so in this case, we have Maya on the right of the screen. And of course, we have Pi on the left. And our biggest use case in the beginning was actually marketing shots. Lighting in Maya does not match lighting in UE4. And an animator would spend a couple hours trying to get a very nice facial pose for a marketing shot. But the minute you bring it to the Unreal Engine with different lighting, that facial pose would not look great. So this allows the animator to instantly see what the lighting situation looks like when you're modifying the face. Another component of Fortnite is that we each have a host of different skins that all share animations. And if we are doing a marketing shot, we want to make sure that shot will look good on that actual skin. Well, in Maya, everything is animated on the character you see, Jonesy. He's like our basic default medium male. All animations, all emotes are animated on him or the female version. And so this allows us to still modify that animation pose in Maya and see it on whatever skin we're going to ship with. And it allows us to, get around clipping issues. In cases where the character has a lot of anim dynamics and cloth, it allows us to see how our animations will react with those in real time. This sped up iteration big time because, used to you do an animation, export it, import it, see the results, and restart the process again. We also use Live Link for motion capture. So Fortnite is all hand-keyed animation. The pipeline for Fortnite that's just where the line was drawn. It's hand key only. However, Paragon was motion captured mostly. So what we would do is go to the mocap studio, load up Live Link plugin so we could actually see our avatar as they would look in game. And it would allow the actors to see what they look like. I mean, it gave them a virtual mirror where they could actually walk up to a big screen we had on the mocap stage, see themselves as the character they're playing. So Live Link has been huge for us. And like I said earlier, here's an example of we could test out emotes on different characters that might have skirts, dresses, capes, and other things. We could see how our animations react with those in real time. LiveLink also works with other things like Steam VR. We used it for our Siren demo. So what you see below, we had an actress using, I believe we used an OptiTrack system at the time, with facial capture with gloves that were taking her hand. So we actually had 3 LiveLink plugins running at once, being time coded and synced together to get a final virtual performance with no post cleanup. It was all done in real time. And of course, we could use UE4's recorder to record that final performance. And we got really good results. And we're continuing to push this more, especially with getting better syncing abilities between different LiveLink plugins. And also to point out, the LiveLink plugin works, for example, in Maya, you have your hierarchy of bones, your pelvis, your spines, your arms, and that's of course driven by an assortment of different rigs you may have. LiveLink only cares about what is being driven. It's just going to look at those bones in space. You don't have to bake them down. It's just always evaluating where those joints are. It does not matter how you drive those joints. And this has been insanely powerful for us. It just opens up the doors for performance capture, puppetry, just testing different things, getting motion into UE4 very quickly. Here's our roadmap for LiveLink. Most of this is in now. Q3, I believe Leap Motion is in, and OptiTrack may be in as of now. I can confirm later. And we'll continue getting more plugins for different apps. It essentially just requires someone talking to us and asking if they can become part of this. So Control Rig is something that we just started this year, and it is what it sounds like. It's a control rig like you would have in Maya. It's constraints, point constraints, orient constraints, parent constraints, all the things you do to build rigs in your DCC apps, only you can build rigs in UE4. And the rigs are built like in the blueprint graph. So it's a blueprint-like graph where you can set up your IK, your controllers, your orients, and your constraints. So it's a scriptable rigging system. And it can be used in an assortment of ways. So you can use it, down the road, we will have it to where you can control your game character with this sort of control rig the whole time, where you're only animating the controls that pull a rig around versus the bones themselves. Currently, right now, we do allow you to animate a control rig in Sequencer. But right now, I would say as an animator, the tools are more for like blocking levels. So if you're trying to create an animatic in Sequencer and you want to get some motion on your character, you can, animate the endpoints of an IK handle on the hands, or, animate the head turning in the scene. Down the road, we'll give you more tools to like map bake data onto control rigs, just as you would in Maya. And this will allow for more like robust retargeting. You could do a lot more with the animation inputs you bring into. You could have your motion capture that you're streaming in. Say it's like a Vive puck. You can move that around, knowing that's controlling a control rig in real time. So this is super powerful stuff that we're going to continue on developing. And the next thing I want to cover is a pose asset. So whenever you're rigging faces, each face has its own assortment of poses. So I don't know if any of you guys have used face effects in the past or any other facial systems. They generally require like a fax-like pose list that can be like 20 to 50 to 200 poses. And we have a new asset now in Unreal Engine 4 called the pose asset, where you can store these poses. And each character will have their own pose asset, but they can share animation from other characters. So let me give you an example. So each of these characters have their own pose asset, so they each have their own custom sculpted poses for their needed list of fact shapes, but the exact same animation is driving them. And the animation that is driving them is float curves. So each pose node has like an associate curve just a float curve. So it's not baked joint data. It can be, the float curve can drive poses. The poses can be created with joint offsets or blend shapes or a combination of both. And so in the case of Fortnite, this allows the animator to create one animation performance, say for an emote, but it will carry through to different characters. And we also wanted to see how far we could push this concept. So one of our riggers took a Fortnite animation and brought it over to a Paragon asset just to see how well shared animation comes across. And so this really helps us extend, because when it comes to animation, especially for a game, you want to do more with less. And if we can have these performances that are shared, say for emotes, this has been huge for us. And then the last thing I want to cover are virtual bones. And virtual bones for us came about from it actually came about from just a kind of a kink in our pipeline. And so what would happen is, let's say when we would get a skeleton delivered to us from the rigging department, let's say a weapon bone might have been parented to the root instead of the right hand. And let's say, we as animators don't look under the hood of what the hierarchy is. We would do an animation set, get it into the editor, and realize that, if you have a weapon bone parented to the root and not the hand, it's going to interpolate in translation space while your hand is interpolating through rotation space. And so we'd get something like a weapon floating off the hand. And the way to fix that is go back to the rigging team and say, hey, can we please have the weapon bone as a child of the hand? They would update the rig. We would then re-export all the animation. And sometimes that could take like half a day just to go back and forth. So virtual bones came about as a way to essentially do all this in the editor. I think the best example I can give to you animators out here are think of in Maya, when you have a bone with all its world space animation, you create a locator and basically duplicate that world space motion and then allow something in a different hierarchy to follow that. That's what virtual bones do. So it creates a new bone and you tell it what other bone you want it to copy the translation rotation data from, essentially in world space. But that could be under a different hierarchy level. So in the case of a weapon bone, we can say, create a virtual bone off the right hand, have it follow where the weapon bone was that was created off the root. It will copy all that, but now your interpolation is following the arm. And this allows us as animators to quickly actually create different spaces, animation spaces. So a weapon can follow the hand for one animation, or perhaps we want it to follow the root, essentially the mesh space for part of the animation, or maybe we want that weapon to follow one of the spine bones when it's holstered. And it's actually opened up a world where we can create all these virtual bones that can take on any transforms from any other bone. This also works for IK as well. Sometimes you might get an animation that has no IK bones baked in. This allows you to create 2 IK virtual bones that will copy over the data of the feet, and then you can then have the IK, if you set up an IK system in the animation blueprint, that can then follow those virtual bones. And so you have IK without having to go back to the rigging team and reset that up. So that's essentially summarizing what we're adding. So if you think of all these things I covered, we have animation recording, we have live link, we have a lot of ways to modify animation, and that's kind of the picture that's emerging with animation in UE4, is that no longer are animations these little pristine snippets that are coming in from your animators, but it's systems of entire animations, no matter where you get them. And you're constantly going to be modifying them, retargeting them, and you want the tools where it's almost like motion sculpting, with the gameplay designers and your animators, and applying it to different skeletons. And that's where we're taking this going forward. So we're going to have things like more live capture, just different ways to modify motion and to do more with less. And then one last thing I want to plug is, when we shut Paragon down, we wanted to release all the assets to the community to use or just to learn from and backwards engineer them. So this year I've released, I believe it's like 40 characters. I created about 40 anim blueprints. So you guys can download those and backwards engineer those, see what we did. We do have some anim dynamics stuff as well in those anim blueprints that you can take a look at and use for your projects. All right, thanks guys.